we can start. Now we have an English session, and I would like to introduce you to Julia Imlauer, and she has a very interesting keynote session today with the topic how to create a strong software architecture. Yeah, the stage is yours. Have fun, and you too.
Thank you very much. Before I would like to start, I need to do a quick poll with you. I promise you, nothing like before, you don't need to run around, but nevertheless, I ask you to stand up, please. So, please everyone sit down who does currently not code or did not code in their profession. Well, a strong software development audience. Thanks a lot for that. Then the next question, please everyone sit down, who is purely using her or his own code base, no external framework, no library, nothing, purely her own code. Okay. And then the last question, please everyone sit down, whose time expectations and estimations for the features he's developing or she's developing is always accurate. Well, at least a few people standing. It's the same for me. I hope I was the only one, not the only one who's happening or which is happening to her. But I guess it's the same for you. And in this talk, I will talk about where this is coming from. So thanks for your contribution. Now everyone can sit down. Let's have a quick look where this wrong time estimation may originate from. First of all, it could be simply a lack of experience. We don't know the framework, we don't know the code base. We have simply started coding, so it's totally normal. Another reason could be that the milestones are coming up, the product needs to be deployed, and a lot of features are ending up on your plate, and you have a lot of context switches to finish everything. Also quite reasonable that the time estimations could be wrong. Or we all have this one colleague who can code any complex features within 2 hours. So simply over-optimistic time estimation could also be the reason. 2 other reasons could be a little bit more in the backyard. For example, you could be piling up technical debt, or you simply have a bad software architecture. And in this talk, we will highlight a little bit where this architecture or bad architecture is coming from and what we can do about it. So who am I to speak to you about software architecture? So I'm Julia, I'm a roboticist, and I specialized on environmental perception and hold a PhD degree in multimodal data fusion using AI algorithms. Overall, I have roughly 8 years of coding experience in an industrial environment, and I'm coming from an urban search and rescue robotics area over the automotive and avionics part, and I'm now in the edtech sector developing nice edtech products. And I can truly say I love building things from scratch, and yeah, that's where the bad architecture is especially a big problem. So what is actually a software architecture? Martin Fowler puts it the way, okay, these are the design decisions or set of design decisions we wish we could do early right in the project. I mean, it's not a definition, and it's hard really to define what is actually a software architecture, because I don't know any formal definition of it. But what all of these definitions have in common is it's usually about identifying your essential components of the system and how they interact with each other. So how can we identify them, and how do we put in the software architecture? Let's have a quick look at a very naive or idealistic picture. So usually we get requirements from the customer. Let's assume in this case they are perfect requirements. They state everything we need. From these requirements, we can create the features we want to develop and we want to put in our system. And based on the features, we design an architecture and start with the implementation. So far, everything looks good, and we start implementing. And of course, we hope that we get out our shiny product, everything right done, and that's what we expect the outcome to look like. But in fact, what often happens is it looks more like this. We have some shiny features which immediately attract the attention of the customers and puts the focus away from the things which are not that great. But in such a scenario, it's really, really hard to add on features afterwards because we are so busy and trying to keep the ship alive and prevent it from sinking. And we are just gluing together all the technical depth and the holes we put up during development. So this is the problem. And where does it originate from, or where does it come from? It could be, on the one hand, the development process itself. Like, we send out the features at a high speed, like coding the last line of code, it compiles, we just deploy it, without proper testing, without proper documentation, just feature speed. Because we have a high time pressure due to milestones, due to the market, maybe an investor is pressuring us to release the features. Then another problem is, all these branches which were branched a month ago are way behind our main branch, and people tend to develop in their cozy environment and do not integrate when they should, and do it on the very, very last step. And the other problem could be that, when we develop features in a team, we talk to our teammates, everything is fine, we are in communication. But outside the team, we do not talk to anyone else because we are happy within our team and develop our features in kind of an isolated manner. I would claim that to each developer, this is kind of obvious, and this is what happens, but we have nice features, nice tools to prevent this from really happening. What's a little bit more or not so obvious is usually when the problems are coming from the architectural side. So what this means is we are really lacking the big picture, like especially these non-functional requirements, like resources or computation time. For example, is it fine for the customer if he waits for the page loading for 10 seconds, or should it be just 1 second or less? What about the maintenance speed? If we have maintenance windows, how long is it fine to be that the product is shut down for maintenance, or should it be always online? These questions are usually only visible in a good architectural picture. Then what also could be a problem is that we are simply missing design principles. For example, if one component is developed like for a prototype and the other one is developed more for a product which should be maintained for the next 10 years, it could be a big problem if this component should work together. And last but not least, if we have unclear architectural decisions, so we don't know who made these decisions or why these decisions were made, it could become a big problem if we later on have to clean it up. And why is this, for me, so important to talk about this role of the architecture? For me, the architecture and the structure behind is really what saves you during the crunch times and helps you to enable really features fast and develop them and deploy them fast. This is the big role of the architecture. If you don't get it right, you can't develop features fast for a long time because you are just cleaning up technical debt somehow. So when I talk about good software architecture, of course, it strongly depends on your application. You can just imagine it's different from deploying a website or an ML algorithm to the cloud than really implementing it on an embedded system on a robot. So it's simply different. But a few things hold for all the architectures, and that's what I want to walk you through. So first of all, it's really necessary to identify your components, how your data flow is handled, and make kind of a clear picture of that, to be sure which components you have and which data is floating around in your system. Then when you have these design principles, be sure that you deploy these patterns to all the components. So I'm not talking about coding patterns here, but simply the design patterns you choose and stick to them so that they are really obvious to the developers, they understand why you're doing them, and that they are implemented in all the components. Then, really important, interfaces. Design your interfaces and then stick to it and only change it if necessary, if absolutely necessary. Make sure that the components who talk to each other, that they have the same understanding of the interface and they know at which rate they can expect their data to come. Then also make sure that you have a common understanding of your release cycle. If you can, and if it makes sense for your project, I would recommend you to always release everything in a single step. Sometimes it's not possible, but just make sure that you release, you have a release strategy and everyone is aware of that, so that components are not released at the different stages and they can still be interactive with each other. So then, if possible, and this is also, again, if possible, make sure that you have stream-aligned teams, which means that the teams can really develop features from end to end. What is the benefit of it? Of course, if one team struggles with one feature, then you might not be able to develop or deliver this feature, but the other teams are independent from it. And of course, when you are inside the team, the communication inside a 5 to 12 people team is often much, much faster than you have to align with the other teams. So when we are talking about team structure, there's also one thing I would like to mention, which is called something like the Conway's Law. So what this is saying is basically if you already have a team structure, and then you are designing an architecture or your software architecture, it's very likely that you tend to design it just following your team structure and your team communication. So maybe not that that it makes sense on a technical level, but you're just replicating what you already have in your organizational level. And this is a big problem. So I mean, what you can do about it, first of all, you could ignore it and say, okay, this is not a problem for me. I would not recommend it. Then you can accept it and say, okay, I'm aware of it. I will have a second look at the architecture once it is designed. And if necessary, we need to adopt it here and then. But I'm aware of why the architecture is originating from what we have there. And the third part is, it's not always possible, but it's called the inverse Conway's maneuver, which is basically the idea that you first draft your architecture and then design the team structure based on what you have in your architecture. This is, I think, the only way how you could make sure that you have the stream-aligned and end-to-end teams. Otherwise, I don't see, or I see hardly a chance that this could be realized. So, when we say about you have all, let's assume you have done all these things right. You get your architecture, you have the defined components, defined interfaces, good release cycle, and in the end, you still end up with an architecture which looks like this. This is totally normal. So whenever you develop features, whenever you integrate something, you make design decisions. You just need to be aware of the technical depth which you are building up. And this is really a call to action here for you. Be aware of the technical depth and also take your time to reduce it at some point. Especially for the product owners or product managers which are in the room, give the team the time to reduce it. Because this is not sustainable. It will block you from developing features fast. And we are not talking about years, we are talking about just a few months, and this is exploding. I speak out of experience. So this is really my key takeaway from this presentation. I strongly believe in that the clean architecture saves you during crunch times and is the only way how you can develop features fast. And it takes constantly the effort to keep it clean. So you constantly need to reduce the technical depth which you are building up. So I would like to say thank you, and if you like to connect with me on LinkedIn, please feel free to scan the QR code and do so. And because we are at the ITCS, I have a second announcement. So if you consider yourself a full-stack developer and you're currently looking for a new role or new experience in the edtech industry, please also feel free to reach out to my colleague Annika, which is sitting here in the back, or to me. I can tell you a little bit more about our cool edtech project. And yeah, I would like to say thank you.
Thank you so much for that interesting tech talk. Do we have any questions here in the audience? No, okay, yeah.
Thank you for the great talk. And I have one question. I think that a lot of the architecture ideas often fail at a certain point when it comes to actually implementing it, especially in startups. I think startups one of the early startup problems is that they tend to over-engineer stuff, right? And they have a small team, they just need to get going, they need to push out features in order to prove the concept. Can you understand me? No? Okay. It's not out now? Okay. So in early startups, there's often the problem that they over-engineer the architecture and they focus too much on building something the right way instead of building something, right? So at which point would you think, or like what would be your advice, where should you actually what be indices indicators to this is the moment, now you should start implementing a certain kind of software architecture, focusing on actually building clean code? When is test-driven development a thing? How do you deal with that? That's a major problem for a lot of early startups, especially, I think.
Yeah, well, I think the startup sector is a special topic here, but my recommendation would be you need first a prototype or an MVP to demonstrate that your business idea is working. And this could be really a hacky solution to demonstrate, okay, the business idea is working, because by then you usually already understood which tech stack you really need and how you implement it. And from that point of view on, really start with a clean architecture, test-driven development, and make everything more cleaner. So when is the point reached where you say, okay, there is no way forward with the current architecture? I recently had that. It was really like when you think you're developing a feature which should take, based on your experience, half a day, and it turned out to be a 2 weeks integration effort because the framework is broken at some point and you need to push through the whole punch of data through channels you had never heard of before, then you know, okay, something is broken here. So recommendation is for the startup, do the MVP, then get the things right and done. If you already have an architecture, if you see that your time estimations go really off, also from the experienced developers, then you need to do something about it.
More questions? So I think you will still stay here for a little moment so that you can ask her some questions if you have one. And thank you so much for your nice presentation today. A big applause for you.